All right, this is a angular momentum problem like we did in class. It's exactly the same example we did in class. We showed you, right, how if you have somebody spinning with their arms out, that's a big moment of inertia. So when they bring their arms in and they lower the moment of inertia, the angular velocity has to go up to conserve angular momentum, right? So your initial angular momentum has to equal final angular momentum. And that's I initial times omega initial equals I final times omega final, right? So I'm basically solving this equation for final angular speed, right? So I'm solving for omega f, right? I'm going to solve this equation for that. And that's easy, right? I'm going to leave that to you. Okay, so I have my initial angular momentum, right? So this is omega naught, whatever that number is. Okay, but I need to get my moments of inertia. It doesn't just give me the moment of inertia. I have to calculate it, okay? So I need to find out my initial moment of inertia first. So the moment of inertia of the stool plus the student is 7, right? So the stool is 7 kilogram meters squared. So here it's 7 also. But where these masses are is changing, right? And so for a point mass, each point mass is mr squared. So that's mr squared and that's mr squared, right? And then same thing here. This is mr squared and this is mr squared. And because we're assuming both of these are the same distance away, right? My initial momentum is going to be the stool plus 2 mr squared. Because there's 2 point masses, right? So it's this mr squared plus this mr squared. All right, and do I know the mass? Oh yeah, I know the mass. Each one is 4, and extended they're 1.1, right? So mine would be 7 plus 2 times the mass is 4 times r squared is 1.1 squared. Right, so let's do it like this. That looks better. So I would do 7 plus 2 times 4 times 1.1 squared, and that would give me my initial moment of inertia. And then I'm going to do the same thing for final, right? So final moment of inertia is going to be the stool plus 2 mr squareds, right? There's 2 of these. I should probably draw that like that up there, but whatever, right? Same thing, except now down here, up here, r was 1.1. Down here, r is 0.27. So here, r is 0.27. So see how that number got smaller? That's why the velocity is going to go up. So if I was doing this one, right, mine would be the stool, which is 7, right? It tells me my stool is 7. 7 plus 2 times, the mass is still 4. 4 times my r squared, that's 0.27 squared. And that'll give me my final moment of inertia. So I can take my final and my initial, and I can take my initial angular velocity, and I can solve for my final angular velocity. So not a complicated problem, just doing conservation of angular momentum. The only thing is we had to actually calculate moment of inertia by adding the stool plus where these weights are.